Hi class, so this is the explanation video for the 0-point pop quiz, and basically this is what we would call a heating curve problem, and it's a pretty standard problem, and sort of the thing I'm trying to illustrate here is we can do a problem in one direction and sort of have a method for how do we solve that problem, but if I just switch it so that we're solving it for a different, unknown or from a different perspective, then we get a little bit lost, right? And so when I say you need to explain every single step, understanding why you're doing every single step, that's how you're going to be able to apply that information for, problem A to a problem like this or to whatever other problem I give you. And these types of problems, there's so many different ways that I can ask you the questions that you really need to have a good understanding of why you're doing every single step of the way to get to your final answer. So this is what I would have done to sort of get started on this problem. So as soon as this was passed out to me, I would have highlighted basically the key point information, and I would have drawn this little diagram. I did notice that a lot of you drew this little diagram. If you did not draw this diagram, please try to get in the habit of drawing a diagram that looks like this for this type of problem. It will help so much. I can't stress that enough. So things that I highlighted: 43.9 kilojoules of energy is applied to 100 grams of ethanol. That's the first bit of information. The ethanol starts at minus 114, and we go to a final temperature of 21. So I'm going to use this information to build my picture over here. I'm also told that the melting point of ethanol is minus 114. So I'm at the melting point, it's just that it's in a solid phase and I need to convert it to a liquid phase. For step 2, I'm just going to be heating it up. So minus 114 to 21 degrees Celsius, that's going to be a Q equals SM delta T type equation. And I'll need the specific heat, right? The specific heat capacity, that's what the information that I don't have is. So I will need to figure that out. That's going to be the unknown that I'm solving for in this case. Okay, so I think this all is pretty self-explanatory. I've got my delta T, I've got my number of moles of ethanol, and the first sort of key point here is that energy 1 plus energy 2 equals the total amount of energy that I have applied. So as we go this way, right, this is energy applied, and this 43.9 value, that's the amount of energy that I applied from the beginning to the end, and these are the two-step processes that I'm going to go through. So 1 plus 2 equals 43.9. And for step 1, we can go ahead and calculate that amount of energy straight away. So we know that this is our enthalpy, right? So 4.90 kilojoules. So that's going to be my delta H equals 4.90 kilojoules. And that's per mole, right? So that's per 1 mole. So here I've got 1 mole of solid ethanol going to 1 mole of liquid ethanol. That's my enthalpy, that's the amount of energy it takes to do that. So if I multiply that by my number of moles, 2.17 moles, moles is going to cancel, and that gives me 10.6 kilojoules of energy. So this right here, this is the amount of energy required to convert 2.17 moles of solid ethanol to liquid, right? So these little sort of notations, I would really recommend if you're struggling at all in this class, if you're struggling on problems like this, start writing out these notations. I've been telling that to a lot of students, and this is really going to help you understand why you did what you did each step of the way. Okay, so this is my energy required to go from this point here to this point here, and now we sort of need to put the rest of the pieces together. So I might say, well, if this is my total energy, (10.6) plus 2 is going to be 43.9. So then I can solve for the energy of 2. That's going to be 33.3 kilojoules. So what this is sort of telling me is that based on the information that I have, this is the amount of energy that I apply to go from minus 114 degrees Celsius to 21 degrees Celsius. That essentially becomes my Q value, right? So for 2, Q equals S times M times delta T. Now we're looking for S in terms of joules. So I'm going to convert this 33.3 kilojoules into joules. So that equals 33,300 joules. Okay. So now for my last step, basically, equals S, my unknown. My mass is going to be 100, so I'm going to go back to mass here, again, based on the units for my S value, grams, and then degrees Celsius. Also, that's going to be my change in Kelvin, because that's the same in this case. So here, solve for S. S is equal to 2.46 joules over grams times degrees Celsius. Right, so that is my final answer for this problem. Now, once you do this, right, if you are a little confused, why are we doing this, right? Why are we doing it this way? That's where you need to sort of explore that a little bit more. Really, beat it into your mind, the method that we're doing, the reasoning that we're using here to get to this final answer of 2.46 joules over grams times degrees Celsius. Look at the units that we have. This is going to be in grams. This is going to be in degrees Celsius. This is going to be in joules. Do those all cancel out? Does that make sense? This is a great problem. I really like this problem, so definitely make sure that you are on board as we move forward.